Hi folks, we're going to take a look at this question here, and they're asking us to determine the rate of change of the function f at x equals x cubed minus 4 at x equals 2. So again, when they just say rate of change of the function, they give us a particular point, it's assumed that we're looking for the instantaneous rate of change. And we define this instantaneous rate of change as being the slope of tangent. Okay? And the way we defined the slope of the tangent is we looked at what the slopes of the secants approach as we find the slope of the secant between the point at x equals 2 and points that are close to where x is equal to 2 as we get closer. And the way we defined that was using this idea of a limit. What do these slopes of tangents approach? Now we had two formulations for this limit. I'm going to use the first one that we saw. So I'm going to use this one here. So the limit as x approaches the a value that I'm interested in this case 2, okay, of f at x minus f at a, which in this case here is 2, over x minus a, so x minus 2. Okay, so the first thing we're going to do, we notice here that even though we're interested in what happens as x approaches 2, we can't just stick 2 into this expression because that would give us an undefined expression. And so what we have to do is see if we can do some algebra to simplify the expression. Okay, so here we're still trying to figure out what's going on as the x value approaches 2. So I'll just input everything we have. So we have f at x, which is x cubed minus 4. Okay, and we're going to subtract f at 2. So here we have 2 cubed minus 4. Okay, all over x minus 2. So again, we just see where the algebra takes us. Okay, so here we have x cubed minus 4. And here we've got 2 cubed, so 8 minus 4 is 4, so minus another 4. Okay, and again, keep simplifying and see where the algebra takes us. Okay, so here we're left with x cubed minus 8 over x minus 2. Okay, now again, we're stuck with an expression where if I were to just input the value of 2, I'd get an undefined expression. Okay, this is where again we have to see what kind of algebra we can do, and hopefully you'll notice that this expression here is a difference of cubes, which we know how to factor. So let's factor this difference of cubes. So this here is like x cubed minus 2 cubed. Okay, so I'll use my formula for a difference of cubes, and I know that it's going to be, since it's a difference, it's going to be the first minus the second, so x minus 2 times the first squared, so x squared, plus the first times the second, so 2x, and then plus the second one squared, so plus 2 squared, which is 4. And here we see something very nice happens, that we have a factor of x minus 2 in both the numerator and the denominator, so that reduces to 1. So what I'm left with here is the limit as x approaches 2 of x squared plus 2x plus 4. So now what this is saying is, what does this expression here approach as x gets closer and closer to 2? Okay, so here we're going to use an intuitive sort of perspective here and realize that there's no issue with x being equal to 2 now with this remaining expression. So if I think, what does x squared approach as x approaches 2? Well, it just approaches 2 squared. And 2x will just approach 2 times 2. And 4, well, that's just a constant. It doesn't even rely on what's going on with the x's. So unlike our original expression, where I couldn't just input the value of 2 because it would give me a 0 in the denominator, I see with this simplified expression that I am able to just input the value of 2. Okay, so what I get here is I get 2 squared is 4 plus another 4, which gives me 12. Okay, so here what we've managed to do is to actually determine the slope of the tangent. Okay, now compared to what you would have done in the past, where you would have just found an approximation for the slope of the tangent by picking, the point 2 f at 2 and then some x value very close to it, that would have given you a good approximation. But what we've managed to do here, by trying to see where what value this expression approaches, we actually find an exact value for the slope of the tangent. Okay? So what's important here is that it seems as though in order to be able to solve these problems, you're going to have to use some sort of algebraic manipulation to remove the difficulty in the denominator. In this case here, the trick we used was to factor the numerator and realize that you end up with a factor that reduces with what you had in the denominator. Okay, what I'll do here is I'll leave you a question that's similar. So what I want you to do now is I want you to consider the function f at x equals x squared plus 2x minus 5. And I'd like you to find the slope of the tangent at x equals negative 2. Okay, now notice here I use this formulation for the slope of the tangent. If you prefer working with the alternate one where h is approaching 0, you can try that, or even better is try both scenarios and make sure that you get the same answer, that you are able to do some kind of algebraic manipulation to reduce out the difficulty in the denominator. Okay, so give that a try.